Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial on machine learning with PySpark, we're trying to see how to use PySpark to do some simple machine learning activity. So in the previous tutorial we did a simple crash course on PySpark using ppnv and then PySpark. Now let's see how to work with it. So very simple. So this is the simple overview and then simple recap of what we'll be doing in this session. We're trying to see how to work with the PySpark.ml API, and we also have PySpark.ml API, which are two different things. So the PySpark.ml is based on the data frame API, right, which is the current supported one. Then we also have the PySpark.ml lib, which is based on the legacy API, which is the RDD, right, resilient distributed dataset. So this is the current one you should be using. You can also borrow from this, but most of the in the future, I'm sure they're going to be dropping this one. But you can use them to do any of the things you want to do. But let's concentrate on this particular one. So PySpark.ml, right, which is the current one. So let's see what we're doing. We're trying to see how to work with classification, see how to do some simple feature engineering, evaluation, and then we'll move on from there. So I'll come back again to my workspace, and I've created a virtual environment, so I'm going to activate my virtual environment. So ppnv shell. We have already installed PySpark, so you can check the previous tutorial on how to install PySpark. Then you start working on it. So let's see the dataset you'll be using. So the dataset you'll be using is from this particular place, UCI machine learning repository, and we are picking the HCV dataset, which you'll be using most of the time. And what is the question? The problem we are trying to solve is that we want to find whether, based on the parameters given, the person is a good blood donor or the person's blood is having hepatitis C, right? So whether the person is a hepatitis C patient or he can donate blood. And this is the details about it. So these are all the attributes, the category. This is the most important thing. This is our target distribution. We are going to see whether the person falls in this category here, is a blood donor or suspect blood donor. That means that the person can give blood, or the person is having hepatitis. That means the person cannot give blood, right? Hepatitis, fibrosis, or cirrhosis, which is the end stage of hepatitis. So this is what we're trying to do. So I'll come back again. That's finished. Now I've already installed it, so you can just go with ppnv install ppnv. In case you have not done it, install PySpark and then Jupyter Lab, right? In case you have not done that one, you can just do this one. But I've already done this, so we'll just move on straight away and just go with pipenv. Let's move on to our create a folder. If I check here, there's nothing here. Let's create a folder called ML with PySpark. I'm moving to my ML with PySpark. Let's move into it, right? And then let's check it out. So if I come back to my ML with PySpark, I check there we have only the old here, right? And I'm going to create a folder called data, where I'll store my data, and I'll create another folder called models, where I'll store my models, which I'll be saving, right, in case you're working on it. So I check it out, we have my data and my models. Now let's spin up a Jupyter notebook. So pip env run Jupyter Lab, right? That's how to work with it. So be doing everything inside Jupyter Lab. So whilst it's doing that, let's go and fetch our data set. So I'll come back to this place, and then I'll just click on the data folder. Then we will download the data. So I'll click on this to download the data set. Then be working on this particular data set, right? Perfect. So let's open and copy this data set into our workspace. So I'll copy my data set here from my downloads to here, right? There's nothing here, and let's rename it from this to a nice name. So I'll rename this one as we did previously, which rename this one to this option, right? So we're trying to see how to analyze this particular one. So by now that's open, so this is going to be using your default browser, right? So I'll copy this URL that's already open our Jupyter notebook for us. Then I can copy it from here, copy the link, then paste it inside my browser. So we are using Chrome for now, so let's paste it here. It's going to work on it. So this is a simple way of working with PySpark, right? Perfect. So whilst it's doing that, let's see what we can do. Perfect. So that's open for us. I'm going to open my Jupyter notebook from here. Then you start writing everything from scratch. So let's rename it and call this one as ML machine learning, or let's say machine learning with PySpark, right? PySpark. So our task is to be able to do what we had here. So this is going to be the location for our data set. So I'll copy this URL here. So this is going to be ML with PySpark, and what you're trying to do, you're trying to classify or predict if a patient is predict something. That's what our main task. This is going to be our data source URL. this is where the dataset is, right? So that you can have access to it. So let's see what to be doing. I'll come back again and I'm going to load in our package. So we'll be loading our package. It's going to be like this. So from PySpark, right? Be importing the Spark context. So Spark context, right? Then you create a simple session so I'll be able to see the UI, right? As I did earlier on. So SC is going to be my Spark context. I'll specify the particular stuff I want to do. So you can just specify the number of masters you want to use. So master, as we did earlier on, local. Let's use just 2, right? As your system is. going to create a Spark context. Then we'll be trying to see whilst you are doing the machine learning, we're trying to see the jobs, the stages as we did previously. So we're using the UI behind the scene too. Perfect. So now we have created a context. Now I can just see the UI. So this is going to help us see the UI, and this is our UI, right? For the Spark context. So I click on this. Then we're going to open on our default port the particular UI. So there are no jobs currently. There are no 0 jobs. We have 5 tabs. There are no jobs. There are no stages. 0 stages, 0 jobs, right? So let's start with it. I'll come back again to my Jupyter notebook here. This is just to help us see what is happening behind the scene. It's not important, but you can do that to help you get the Spark UI. Right. Perfect. Let's see how to read our dataset to load the packages for machine learning, for ML, right? For reading our dataset, so it's going to be from PySpark, right? .SQL, right? Then you'll be importing the Spark session, so Spark session. Right, perfect. So that's the most important thing we need. We are creating a session, and then from here I can just come back again and then create my Spark, right? So my Spark session builder now specify the particular app, so app name. So as you can see from here, we have no app name, right? We have an app name, but it's not the best. If I check the environment, go back and I check the environment, we have the PySpark shell, right? But I want to give it a good name, so I'm going to give it a new name for the app that we have now. So app name, let's go to say ML with Spark, right? Something like that. Then I'm just going to get or create. That is all. So it's going to create a Spark session for us that we'll be using to do whatever we want to do. Then with this particular Spark, you do all our analysis. Let's see the simple workflow of what you'll be doing, right? So this is going to be our workflow. The workflow that you're going to do some simple data preparation, then you're going to do some feature engineering. Oh yeah, do some simple feature engineering, right? Then later we're going to build our model. Then we're going to see how to evaluate the model, right? So that is all that you'll be doing in this wonderful session of the course. So our task is to do some simple prediction to predict whether a patient based on the parameters is going to be a good donor. So our task, our aim is to predict. This is going to be our task. That's to predict, right? If a patient is hepatitis, right, or not, right, based on parameters. Right? So we're going to predict if a patient, right, is having hep C, hepatitis B, or hepatitis, right, based on, and the person is also a valid candidate, as our task is here. So the task, this is a task we're supposed to do, right? So that is what you're trying to do here. It's a classification problem. Okay, so let's move on and write some code to save us time. Right, so this is going to be everything from scratch. So let's see what we're doing. So first of all, let's load our dataset. And as we can see from here, there are, if I go back to the jobs, there's no jobs, right? There is no job. The jobs are 0, right? But now when we start working on it, it's going to create our jobs for us and our tasks. So df spark .read read CSV. Now passing my data set. So inside my data, I have my HCV data that we work on .csv. Then I have to specify that I want the header to be true so that I can see the header. We can infer the schema, but you can just go without the schema. Then in case I want to preview the data set, let's go with my df.show You can also use df.head. It's also going to work, but let's go with df.show. Now passing the particular value. So as you can see, if I come back here and I run it, because it's reading, if I rerun these jobs here again, you're going to see that it's going to be showing the particular job it is doing, right? Then it's going to tell us when it is finished or not finished. Take some time for it to run. But so that's finished. If I come back and I check it out again, let's click on this. Because you have done only one job, which is a read job, you see that we have the job here, completed job, and you can click on this and see the various information about it. So the job has finished, right? And if I click on this, it's a CSV, right? I click on it, it's going to give you the DI geo map, right? Which is very useful. You can see from here. So this is what it did. So it scanned the test, then it did this host stage code gen stuff, then it did map reduce, right? Map partition of it to be able to read the data set. Okay, so let's come back again. And then let's preview it. So if I do this, df.show is also going to add it to our tags here, right? So if I come back to the jobs, now we only have one job for the read, but if I do a show, it's also going to do another job. So we have two jobs here, right? Very simple. And you can see the stages of the jobs, the progress of the jobs, some very nice metrics. You can see whatever that is being run behind the scene. Okay, that is something simple to help you with that. Now that's it here. It's how to preview the dataset, right? So what you'll be doing is that you'll be trying to change this particular one from here to this place. So let's check for the data point. So in case I want to check for the number of the columns, so check for columns as we did. We'll not be going to details, so df.columns to get the columns. Then in case I want to rearrange it well, so let's rearrange the columns in a way that we want, right? In a standard way, because this is a supervised machine learning program. So we don't need this one. We only need this one, right? But we want to position it also. I'll copy this entire stuff here. And I'll rearrange it. So we can also check for the rearrange. So let's rearrange it. So rearrange. It's very simple. It's going to be my df, right? I'll pass in my df.select. This is how to make a selection. Then I'll pass in my columns. So this is it. And I want to put the category column at the back. So the category column is going to be at the back, right? Perfect. So this is better. Now if I go back and I check it again, 5. Show is the same as like help you to preview it. You can also use head in case you want. So this is better, right? Now what we need to do is that we need to get the data types of it to see what we can do. So let's check with the data types. So you can just go with d types. It's still going to work. You can also check for the schema, and all of them are string. Although this one looks like numbers, it could not infer the schema to give it the right one, right? So you can also use the infer schema to help you with that. So you can also come back again to this and go with infer schema. Let's go to true. You can also use this particular option here. You can also use this particular format. Let's preview it again. So you can also infer the schema. It's going to show it back again. And if I come back and I check the data types from, let's rearrange it again. If I come back and I check the data types here, this is the initial one, right? But if I do it again, so df.dtypes, using the infer schema, now it has been able to pick automatically the right one. So you see that the age column was integer, but here it was string first, but now it is integer. The sex is a string, it's still a string. And then you could see that these ones were all strings, right? But now it has given to us as float, which is quite useful in case you are trying to do your attacks, right? Very cool. So inferring the schema is useful to help you automatically pick and infer the schemes, right? As you have seen. So this is after inferring scheme. So this is going to be, and this one is before. Right, this one is before schema is true, right? Something like that. So that is something very simple to help you, by the way. This makes your work easier. Now let's move on. We don't need to do some more casting. I can also check for the schema. So let's also check for the schema. So df.print schema, it's a function. Then I can also see the schema. So this is going to give you a very important information. So the age is an integer. The sex is a string, as you already know. These ones are all strings, but we have to convert them into a particular type. We have these ones are all doubles, right? That means they are inferred well. And then this one you have to change it. So let's see the value count, right? So I want to get the value count. You can also do descriptive summary. So descriptive summary before value count is going to be df.describe.show. Right, you can also print it out if you want, but it's still going to be the same thing to print. Right, so you can also get the descriptive summary of the entire data set. Then let's move on to do some other stuff. So all these jobs that are being done, if you check your Spark UI, you can see that it is still going to be showing the various jobs and the stages for each and every of the job, and then the environment. It says that you have done 6 jobs, and these are all the various information. It says that the one we are doing now, the describe, is still running, right? You can see that it's still running. These are all the things we have done. And if I go back and I check the SQL, you can also see that with the SQL, you can see some new information there, all the jobs and the queries that have been made behind the scene, which is very informative, very useful. Now you may not see how performant it is, but you see how performant it is if it is big data, right? Very, very huge. This is a small data set. Perfect. This is not that clear, but you can pick one particular format. Now let's see some other stuff you can also do. So what you want to do is that we want to get a value count. So value count, right? So it's going to be df.groupBy, as you saw earlier on, group by. We want to group the category, so category column. I want to get the count of it, so dot count. So this is going to give me the group by, and in case I want to see it, just go with show. Right? So I want to see the percentage of my data set, right, for the category column. What is the value count of them, to see whether it's a balanced data set or not a balanced data set. Perfect. So that is all, right? You have gotten that most of them. This is a blood donor, and then these ones, this is 7, right? And this one is this. So you can just keep this one as it is, and then this and this and this are also going to be their own. So let's see how to do some simple vectorization. So that's going to be the next step, how to do vectorization. So this is going to be my feature vectorization. Let's go with feature engineering. I'm trying to convert them to numerical values. So numerical values, so which can also be like vectorization, but based on the dataset vectorization, whether you can do scaling or not, right? Based on the data, so you will see whether we can do scaling or not. But I don't think we need scaling in this task. You can also do scaling, but based on what we have. So df.show this, the first 5 values. I do not think we can, right? We can do scaling, but most of them are almost within the range of 110. So scaling may not do anything, but we can still do the same thing, because these are almost the same, within the same range. What you need to do is to change this particular one to numbers, right? And you can actually split them to make it easy for you. You can actually split them on this. You can actually split them, but let's see what we can do. You'll be taking this particular column, which is string, and this column, which is also a string, and then vectorize them using the features. So we're just going with this option. So from PySpark.ml, right, dot feature. So there are several. So before we move on, let's preview it first. So I can just import PySpark.ml, right? And with PySpark.ml, you can just check all the various things we can do with PySpark ML, Spark.ml. These are going to be all the methods and attributes. So we have an estimator. So an estimator takes in data and then produce a model. And we have the model itself. We have the transformer. Transformer takes in data and produce data, right? As we learned earlier on some time ago. And a pipeline is used to keep everything together as it stages, right? So a pipeline is a combination of transformers and an estimator, or transformers and transformers. Okay, so these are the stuff you can do. You see that we have recommendation. If you want to do recommendation, we have feature to work with feature engineering. We have evaluation to work with evaluation, clustering to do classification, clustering for clustering, classification for classification, and then regression for regression problems. So let's import our ML packages. So I'm going to be importing our ML packages. Maybe from PySpark.ml, right? We need a feature engineering. Then I'm going to import what I want to do. So you can import this one. There are a lot of things you can do from that. We can do it this option here, or just go with my vector assembler. So we have the vector assembler, which allows us to be able to create vectors from an array, right? From our features. We also have the string indexer. So the string indexer allows us to be able to convert strings into index, right? Which is very useful. So these are the two we want to be using. and let's see how to work with it. So the first one is that we already had our column for the male, column. For the gender column, we want to convert this one into zeros and ones, right? So how do we do that? So in case I want to get the unique values there, for the sex, right, it's going to be df, but as we learned earlier on, select, then just specify the column, which is the sex column. Then from here I can just go with my distinct to get the distinct values there. So we can now just go with dot show. So this is going to tell me that we have only just 2, male and female there. Then we can now map them, we can now encode them into ones and zeros. You can also apply a function on it, but let's use the default one that is inbuilt. So we have male and female. Then how do I encode them, right? So you can actually encode them with the string indexer. So in case I want to convert, I want to convert this the string, right, into numerical value, numerical codes, right? This is like encoding, right? Label encoding, something like label encoding, right? So it's very simple. So I can just come back again using a string indexer. So I can call it as my gender encoder, right? Encoder is too big, but let's take it like that. Then I'm just going to use a string indexer. So string indexer, and I'm going to specify the column. So input column, so the column I want to pick, which is going to be the sex column. Then I'm also going to give it the output column, right? What I want it to be called. So output call. So the output column I can call it as, let's say, sex. Let's call it as gender, right? Something like that. But we see that they are different. Perfect. So that is all. So this is going to be an encoder. Then now we can actually fit the data set. So before we even create the encoder, I can actually fit it here. So dot fit. And passing the data set. It's going to look inside this data set, pick the sex column as the input. Then it's going to map it and fit it for us, right? And then store it inside a variable called gender. Then from there, I can now use that gender encoder to be able to encode the entire data set. So this is a transformer. So this string indexer is a transformer, right? So it's going to pick in data and then produce data, right? So I'm going to fit on the data, then I want to get the data back to df. Then I'll just go back with my gender encoder, right? Encoder. Then I'll just go straight away with my transform, now passing my data set. So this gender encoder is going to look through this data set and transform it. So if I go back and I check it again, 5, you can see that now it has been encoded. So initially it was sex, right? But because you have encoded it, now it is 000, right? Which is what we'll be using. So we're doing the same thing for this particular column here. So the same thing. Now can I just come back again? Let's do some encoding for the category column. This is still like label encoding, right? But this we're not using one hot encoding. There's also one net encoding, but let's do the simple approach. So it's going to be the same thing. So I can go to my cat encoder, then string indexer. Then I'll pass in my input column. So input column. Then I'll specify the column. So category. You can also replace it with the same thing. So output column. Let's call this one. Let's call this one as my target, right? So that it looks different. Then I'll fit it to the data set. Then from here I can just say my df, pick that cat encoder, and then do some transformation. So this is a transformer. So transform this data set. So it's going to pick the category column here, then it's going to give me the output as my target column. Right? So if I go back and I check what we have now, so df.show first 5, you can see that now it is given to us in a very simple format, right? So you see that we have our category column encoded well, right? Very, very cool. So what we're doing is that you'll be dropping this, you drop the sex, you drop the category, and you're going to pick only these ones, right? So the rest are okay, the rest are numerical. So let's pick them out. In case you want to get the labels, right? In case you want to get the labels, right? Of, let's say, this particular cat encoder, right? You can just do this one option. The original labels is going to be my cat encoder dot labels. If I go with this, it's going to print out the labels for us, right? So this is it, right? So we can, in case you have lost you have lost track of where the labels are. This is the labels there, right? Perfect. That is the simple overview of it. And you can also get the index back again, right? So using this option, so this is going to be the index to string option. It's going to be from SQL, from PySpark .sql.ml .feature import the index to string. In case you want to get everything back, right? In case you want to get everything back, so from PySpark.ml import index to string, then let's call that, let's say, my converted data. So converted, let's go to converter, right? Let's do this, let's say converter for, let's say, the category column. So I'm going to go with my index to string, right? And I'll just pass in the input column. So input column. So this input column is going to be the new one that we had, which was the target, right? Because that's what we want to convert. Then the output. So let's call this one, let's say, original cat, right? Something like that. But then, as we did earlier on, we're also going to fit it on our data set like above. Going to fit and transform it, right? So you can also do the same thing here. So this option here, right? So there's it. Then you just transform your data right on it. So it's going to be this option. So let's call that my converted data frame, which is going to be this option. So converter, the new converter I've created dot transform. So converter dot transform. Now pass in what I want to do. I'll pass in the initial data set that we had. So it's going to look at it and then check it for us. So if I go back and I check converted data frame dot show, if I check it out, it's going to convert back that particular column. So now it has given to us. So this is the original one we did. This was the targeted one, and it has given to us the same thing back again, right? So in case you want it back, you can use this particular option to get it back again. Perfect. So that is something, by the way. Now let's go back and see how to build our features. So this is going to be our feature. Yeah, let's go to the features that you're going to be selecting. Yeah. So we have it like df.show. This is the initial one, but I want to pick some columns. I don't want to use everything. I want to use everything here without this one. So I'll drop this one, I'll drop this one, then we'll use only the numerical one. So let's call this one as a different format here. Come back again to what you have done so far. So I want to just pick these ones. We can drop them, but we can actually pick the ones we want, only still maintaining the data set. So let's do that one. So I'm going to call it as my vectorized data set. So let's go to my required features, right? The one I want to use. So let's bring out everything that we need. So df.columns. I'm just picking the ones we need, right? We don't need this one, and then we don't need, we don't need this one. So we'll just be picking the ones we need. So I'll copy this entire stuff here as my required. I'm going to pick the ones we don't need. So we don't need the age. We need the age. We don't need this. We have given it as a different one, so I can actually put it in the right place. We don't need this one here. And to conform with our initial data set, let me arrange it well. So I'll put the gender in front where it was supposed to be. Right, perfect. So these are our required columns, right? The column that we'll be using for our machine learning activities. Now let's vectorize them, right? So to vectorize them, I'm going to create my vectorizer option to help us with that. So it's going to be my, so the vector assembly is going to be used to do that. So it's going to be my vec. Can give it any name. Then I'm going to take the vector assembly, so vector assembler. Then I'll put in the input column, so input columns that I need, which is going to be my required columns, required features column. These are the ones I need, right? Then the next one is going to be my output column. How do I want it to be called? So output call, and I'll specify that I want to give it the name call features. That is also, this is a basic way of working. So this is going to create a vector assembler for us. Now let's fit and transform our data. This is also a transformer, so to work on our data, call it as my vectorized data. So vec df, I'm just going to go with my this option, so vec assembler, then I'll just fit on it, right, transform it. I'll pass in my initial data frame. It's going to look at that particular data frame, pick the required columns. It's giving us an error because we spelled it wrong. It's sampler, right? This is the same, this one here, we spelled it wrong. Let's check the spelling. So looking at this, it's giving us an error. So the error is giving us is because of the type, right? You know the type, so data type wrong. If I check back again, let's go back a little and check the data types first before we move on. So df.d types, most of them are still strings, right? We need to convert all of these things that are strings, all of these things into float, right? So how do we do that? So I can just use a simple option from PySpark, but let's use pandas. But we can also use pandas to help us with that, right? You can use pandas to cast the entire stuff to it. So what I'll do is that I'll pick the column that we need and I'll convert the entire stuff, because the column we need now, all of them are in float, right? So I'll just copy this entire column here. These are all the columns that we need. They're already in numerical value, right? So I can just go back again and do this. So df.select, right? I'm selecting only those ones. I'm selecting all of these particular columns here. Then I can now just show. If I show it out, it's going to give us our result. This must not be here. So these ones that we have here, this is all the data that we'll be using, right? And all of them, as you can see, they are all numerical value. But if you check the data types, some of them are strings. So we'll be converting and casting the entire stuff into float, right? So let me save this one into, let's go to the data frame 2, right, to just save it like that. Now I'll just change this one off. Perfect. So if I go back and I check it out, to confirm dot print schema of this entire stuff, to confirm we still have some strings here, so I'll be casting them. You can actually use pandas to do that. You can use PySpark to do that, but that's going to be another tutorial. So let's do it in a simple way by coming back to this. So we can just do df2, right, dot 2 pandas and convert the entire stuff to pandas. Then from here you can just go back again and then you cast it, right? Cast, then you cast it to the particular one you want to do as type, right? So this is going to be dot as type. Let's convert the entire stuff into float. So you can actually do this one, right? So it's going to convert. This is a simple approach, right? You can also use the types from PySpark, but I want to use this particular option. It's giving us an error somewhere. Let's fix that particular error. Because there are some missing values there. Okay, so you have seen that there are some missing values there. So you have to drop all those missing values and then work on it. So let's check it out. Okay, so I was checking the back. So it was still giving us this particular error, right? So how do you fix this particular error? Because you're already in pandas, right? You can actually check for the missing values and use Spark. Spark is also have df, can also do this. So df2.fill now, then you pass in now, and you can also pass in the subset of the place you want to fix, right? Let's say of the different columns that you want, right? Let's say column 1, column 2. You can also do this one to fill the missing value. But based on what you are seeing here, based on the error we are having here, the error is saying something very, very fascinating. It's saying something here that we cannot convert string, right? Cannot convert string to float any. So this is the string there. So you have to either replace a particular string from it or use a different format. But since you're already in pandas, we have already converted it to pandas, right? That is where pandas can help you. I can just convert this one here. This is another option. I can just convert this entire stuff. I can just replace that NA that we have. Can replace, right, the NA. I want to replace this NA, which is the NA that we are having here. NA means not available. This NA we are having here, I can replace this particular NA with 0, right, instead of filling. There's another way we can also clean it, right? So dot, I'm going to replace this one with what? 0. So if I run it like this, now it's going to replace the entire stuff with 0 for us, right? And now I can just convert it to as type. to float. Now it's going to convert the entire stuff into float for us, right? So you can actually work on it. So I just call it as 3 to save us time. So we'll be doing it on this particular data set we had. This particular one we have, which is the required. So I just call number 3 to save us time, right? So let's work on it. And so that's what. So let's apply the entire stuff here. So df2, right? And let's apply it. It's going to work perfectly for us. And let's equate this df2 now. So this now is no more in a format of if I check for the type of this, right? The type of this is now in the pandas data frame, right? Not PySpark data frame, right? Which is different from this one, which is different from the df.1. The df, this is different from this. This is inside PySpark data frame, right? So this is totally different. So what we need to do is that we are going to convert this one again back into PySpark before we work on our vectorization. It is something that I didn't even plan for. Okay, so let's convert it back. So I'm going to convert it back. So convert to PySpark data frame. Simple. It's going to be like this. We already created a context. We can also use that particular context to help us with that. So I can go to my df3. Let's go to df3, or we can just give it any name that you want. So df3, or we can let's make it new df, new data frame. Right, this is going to be my new data frame I'm creating. Going to be my Spark that I have. Right, then I can just go with create data frame. Now pass in my data frame again. So data frame 2. So this is another way of working with it. Right, so if I run it like this, now it's going to work perfectly for us. So we have created a new data frame. So this is a new data frame we're using for our vectorization from henceforth. So today you're able to see the errors I made, right? Which is good. I hope at least you're able to learn something from it. So if I go back and I check it out, this new data frame that I have, and I check the show now, you see that everything is in numbers, everything is arranged well. This is what we'll be using to do our machine learning activities. And then from here, I can also check for the, so everything is working well, right? Very cool. Pre-corner, right? Perfect. And from here, I can now check for the schema. It's going to be df.print. Now it's new df, so new df.print schema. Now everything is going to be in. So if I check the schema now, you can see now most of them are now double, right? So you can actually now work on the vectorization because everything is numerical value. So let's move on in the next session and see how to do that. So I'll rerun this one again, right, as we did earlier on, and then we're going to apply it on our new one, not the old one, the new one. And as you can see, then we have already transformed it. If I go back again, I check out, so my vectorized data frame dot show. Let's just show the first 5. You can see that now this is going to give us a different type of data structure, right? Transformers picking data, then they produce data. So it has taken the entire feature that you required and then place them into a vector, right? Which is this one. So this is what we'll be using to work on our activity. So the next session is that we'll be trying to see how to split our data set into 2. This is going to be our train test split. Going to be our train test split. Right, in case you want to split your data set into 2, let's see how to do that using PySpark. So PySpark already have most of these things already implemented. You don't need to import another package, right? It already inherited from the dataset. So now I can just go back with this. So let's go to my train dataset, df, and my test dataset. Right, and I'll just go back with my vectorized dataset that I have, dot random split, right? Then I'll specify how much I want to split it. So it's going to be 0.7, 70, 30, then 0.3. So it's going to split them. So the training data set is going to be 70, and then the testing is going to be 30. So this is how to do that, right? So random split, and it's very fast. Now if I check it back again, df.count So now it's going to give us the result of that particular one, not like the initial one, right? There's another way you can also work. It's 439 out of 619. Very cool. So we have seen how to split our data set. Now let's see how to do our model building. So you can use any algorithm. So this is where we have two different sub packages to help us with that. So as we saw earlier on in our picture, we have the spark.ml, which is used to work on data frames, and we have the spark.ml lib, which is usually used for RDD, right? But we're using this particular one. So I'll come back again to model building. So we are using the PySpark.ml, right? And then in case you want to do more metric stuff, just go with PySpark.ml lib, right? This one is for RDD, and this is legacy, and this one is for data frame. Right. So let's see how to approach it from here. So be using logistic regression because there's a classification problem. You can use decision tree, any of them. So I'm going to import them from PySpark.ml, right? Classification. Can I import the particular library also, logistic regression classifier? So we have logistic regression classifier, we have a decision tree classifier, all the various classifiers that you want, right? So I can come back again, logistic regression. You can also go in decision tree classifier, right? So something very simple like this. So this is how to work with it. So from PySpark.ml, import logistic regression and then decision tree classifier. So let's build our first model. So we're building a logistic regression model, logist model, right? So it's going to be my LR model. I'm going to initialize it with logistic, just like in case you're working with scikit-learn. So all of them is together, right? That is one advantage about PySpark. It's including both the data frame aspect together with the machine learning aspect all together in one package. So you don't need to even go anywhere. Regression, right? Then inside this particular estimator, you're going to specify the features column. So features column for data set, which in this case, my features column is going to be my feature. Right, this feature is coming from the feature that we had here, this particular feature here, right? This particular feature here, which was the same name we gave when we were trying to give our features here, right? Perfect. Then you also have to specify your labels column, which in our case it is called target, right? So we'll be picking our labels column as part. So my features, then I'll specify the label column, which is going to be my target. So when you pass this model on it, it's going to pick that particular columns. Perfect. Now let's see how to fit our data on it. So let's call this one as LR rather, right? Let's call this one as LR instead of LR model. Let's call this LR. Then I'll just fit it on it. So it's going to be my LR model. I'm going to call this my LR.fit. I'm going to fit it on my data set, which is going to be my train df. So it's going to look inside that particular data set and pick only that particular column, right? Based on our data set that we have, if I check it back again, you can see that if I check this one, so train df.show, if I check this one, let's just see the first four values, you will see that it's only having the feature. It's going to pick the features column and the target column and leave the rest. Perfect. So that's finished. If I check it out, so this is what I mean, right? If I check out this, it's going to pick this one and this one, right? So that is what it picked. It's going to ignore all the rest, which is very useful, right? Perfect. Now that's finished. Now in case I want to evaluate it, I can actually get the right prediction. So let's go as my right prediction. Go to my LR model, then transform. Now passing my test data set. So test df. So it's going to give me all the predictions for the entire stuff, and I can now view it out. So I predict show, you can see everything out, right? So this is how it's going to be. It's going to give you the entire data set that we have together with the feature and then the target, and it's going to give you the raw predictions, right? So you can actually select them in case you don't want it like this. You can select the probability, the prediction, and then the raw predictions. Let's do that one out. It's going to be my y pred.select, because this now can just go with this option in case you want to see it columns. To see the entire columns there, then you can now pick it out. So let's make it print to put it horizontal. I don't know whether I'm speaking too much in your ears. Apologies for that. I want to get these ones. So you can actually get only these ones, which is going to be my y predict. So y predict.select. pass in the columns you want to pick, and then now you can just go with dot show. So this is going to pick only that particular column for us, and their probability. So this was the raw prediction and their probability for all of them. You can also even add a target to it to compare and see how accurate it is. So target. And it's going to pick it and give us the result. Most of them are correct, right? So it is very, very interesting. Now, how do you get the accuracy score? How do you get the accuracy score? So this is still part of evaluation of the model. So let's see how to evaluate our model using PySpark. So this is going to be model evaluation. So I'll show you the first approach, then I'll show you another approach, right, in which you'll be using the PyML to help you with that. So how do you check for the accuracy score? So you can just come back again. Let's see how to do that. I'm going to go with this option. So from PySpark.ml.evaluation, import. This is a multi-label classification problem. So multi-classifier. So we have multi-classifier. So multi-class classifier. There's also binary class classifier. There's one is classifier. Right, multi-class classification evaluator. So multi-class classification evaluator, because this is evaluator. Right, so this one is going to be used to help you evaluate your model, right? So you need to create a simple instance of it. So let's go as evaluator. Then I'm going to create an instance of it. So multi-class classification evaluator. Then I'm passing my values that I want to work on it. So this, right, then this is going to take the label column. So the label column is going to be the column that I want to pick, which was in our case was our target, right? And then the next one is going to be the metric. You can also go without the metric name. So the metric I want to get the accuracy, right? So this is going to create a multi-class evaluator. Then I'll use this multi-class evaluator to evaluate my model. So multi-evaluator.evaluate. I'm passing my y print. So if I go with this, it's going to analyze and give us the score for that particular one. So that this was able to give us a very high accuracy of 0.99. So that is how to get the accuracy score, right, for your model, right, using this particular option. You can also do more in case you want to get the confusion matrix. You want to do the S-score precision. There's going to be more. Like still, in case you want to do, let's say, precision. In case you want to do F1 score, which is mostly like the classification report, right? I recall mostly these are all classification report. There's no one function for that classification report. You can also use pandas to help you that, but let's move on, and then scikit-learn to help you that. But let's see how to do that. It's going to be from PySpark.mllib, right? This time you're not using ML, you're using mllib. Then you are going to be importing the multi-class metric to help you with that, right? So that is the simplest way. So from this, then just go with evaluation, mllib.evaluation. Then I'm going to import the multi-class lib. So this, there's also binary class metric, but this one we are importing multi-class metric, right? So this is the package you are picking, right? You use this one to help us do analysis. It's supposed to be space here. So let's see how to do that. This is very simple. This one gives you an upper hand over the first one. So it's going to be like this. Just going to go with let's call this as we have our model. So LR matrix, our model matrix. I'm passing my multi-class. So multi-class matrix. I'm going to pass in the data set, right? That we have. Now I'm going to pass in the prediction. So I'll pass in the y predict. So this y predict is the one that we had earlier on. This particular one. That's been a long tutorial, but apologies for that. This one. So I want to pick these particular columns that I want to work on to do the analysis, right? I want to get the prediction and then the target, right? So this is what I'm picking. So I'll pass it here. So I print, passing these particular ones. I'm getting the target. I'm not adding the probability, only these are the most important one. So the target and the prediction, because it's going to compare them to get the result. Then I can just go convert it to RDD. .RDD. Remember that I said MLlib, it's working with the legacy API, so that's why I'm converting them into RDD, right, to be able to process it well. I hope you get the point. So you must convert it to RDD to be able to work with it well. Perfect. So this is going to be our metric, so logarithm regression metric. Then from here you can now work on. So this, if I check it out, DRL, LR metric, we have confusion metrics, we have recall, all of these things are there that you can actually do. So if I check it out, by default it's going to calculate all of them. So you see that you can get the accuracy straight away, you can get the confusion matrix, you can get the F1 measure, right? That is F1. You can get the log loss, you can get precision, you can get recall, you can get a lot of things out of the box, right? So that is one of the ways to be able to get all the metrics, all the classification reports, right? In case you're coming from scikit-learn. So in case I want to get the accuracy, right, you're just going to go with this option. So my LR metric, then I'll just go with the accuracy. So this is going to print the accuracy for us, as we saw, which is the same accuracy that we got here, right? So in case I also want to get the recall and the rest, I can also do the same thing. So in case I want to get the recall or the precision, let's make it like this. I'll change this one from this to, and I'll specify the precision. So precision. Then precision must pick a value. So 0.1 is going to give you the precision. You're comparing it out. 0.8, that is the precision, right? You can also specify the mode that you want for the prediction, right? So let me add the rest to it to save us time. So I pasted it there. You can see that that's giving us our result. Very cool, right? So that is how to do some simple machine learning with PySpark. We have seen how to read in data sets from scratch, which has been a long tutorial. We were able to see how to spin up our Spark session to be able to get the UI, right, using this particular content that we created. And now you can see that if I go back to the jobs, we have done a lot of jobs, right, a lot of tasks by the cluster. This is our singular cluster that we have, which is quite interesting. So we saw how to read our data set, how to create a Spark contest, how to spin up our UI using this particular option, and we were able to see the number of jobs that has been done, which is quite a lot. That is about 109 jobs. You can see all the various things there, right? Oh boy, right? That is a lot, right? And the various things that's done. For the metrics, you can click on it to see the map, to see the structure of how it was done, right? You can see it very well here. You can see the event time, you can see this dark visualization for that particular activity that we called, and all the things it was able to do to be able to give us the metric. Wow, that is quite a lot of things out of the box, right? So we have seen how to work with that. We saw also how to work with simple data frames, how to do some simple transformation and vectorization, how to do some simple feature engineering, how to convert our column from this particular option into numerical values. And we saw how to work with the string indexer and the vector assembler, which is used to create features. And then we also saw how to build our models, right, in this particular option. So we tried with logistic regression model. We have seen how to evaluate it. We saw how to train test split. We have seen how to do some simple model building, and can also serialize and save your model too. So that is something very simple with PySpark. So thank you for watching this tutorial. In case you have any question or contribution, you can just put it in the comment section below, and see you in the next session. Stay blessed. Now, in case you want to save your model, right, these are the two main approach, right? You can go with the model.save. This is one of the approaches, or you can also try this option, right? So any of them is still going to work, right? These are how to save your model. Until I forget. So that is how to work with it. So thank you for watching, and see you in the next session. Stay blessed. Bye. And please don't forget to check the links below for some more materials.